Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about percent error calculations. And our aim for today is, how can we calculate the amount our measured value is off from the accepted value? The formula for percent error is percent error equals the measured value minus the accepted value over the accepted value times 100. Or to write it easier, percent E equals M minus A over A times 100. Practice problem number 1 states, Joshua uses his thermometer and he finds that the boiling point of ethyl alcohol to be 75 degrees Celsius. He looks at a reference book and he finds that the actual boiling point of ethyl alcohol is 80 degrees Celsius. What is his percent error? So, first thing we do is we write our formula. Percent E equals measured minus accepted over accepted times 100. Next, we have to find the measured and accepted values. Joshua measured, he found the boiling point to be 75 degrees Celsius. That's our measured. When he looks in the reference book, he finds that the actual boiling point is 80 degrees Celsius. That is our accepted value. So now we plug in numbers. Percent E equals measured 75 degrees Celsius minus the accepted, which is 80 degrees Celsius, over the accepted, which is 80 degrees Celsius. And make sure you don't forget, it's percent, so it must be times 100. I would take this step by step. I would do 75 minus 80, so that gives us negative 5 degrees Celsius. Then I would divide negative 5 degrees Celsius by 80. So negative 5 divided by 80. Since I'm dividing these two, the units cancel out. Degrees Celsius cancels out. So negative 5 divided by 80, I get negative 0.0625 times 100. So when I multiply 0.0625 times 100, of course, I get negative 6.25%. And I'm going to use significant figures using my original numbers. 75 has 2 significant figures. 80, no decimal point, has 1 significant figure. So I'm going to round to 1 significant figure. This 2 is lower than 5, so my final answer is negative 6%, and that is our error. Joshua was off by negative 6%. That negative means he was below the accepted value. So the accepted value was 80, he came in at 75, which was under. If he came over the accepted value, the percentage would be a positive number. Let's try problem number 2 together. Practice problem number 2 states, the density of water at 4 degrees Celsius is known to be 1.00 gram per milliliter. Kayla experimentally found the density of water to be 1.075 grams per milliliter. What is her percent error? Step 1, write the formula. Percent E equals measured minus accepted over accepted times 100. Then we have to find the measured and accepted values. The density of water is known to be 1.00 gram per milliliter. That is our accepted value. Put a little A there. But Kayla experimentally found the density of water to be 1.075 grams per milliliter. That is going to be the measured value. Now we plug in the numbers. Percent E equals measured 1.075 grams per milliliter minus the accepted, which is 1.00 grams per milliliter, over the accepted, which is once again 1.00 grams per milliliter, times 100. Again, take it step by step. 1.075 grams per milliliter minus 1.00 grams per milliliter is going to give you 0.075 grams per milliliter over 1.00 grams per milliliter times 100. Step 2, you're going to divide. The units cancel out. Grams per milliliter and grams per milliliter cancels out. You can plug that in your calculator, 0.075 divided by 1.00. But anytime you divide something by 1, it's going to be the same number. So of course we get 0.075 times 100. So our answer is going to be 7.5%. We look at our original numbers, 4 significant figures, 3 significant figures. So our answer, the least number of significant figures, should be 3. So this is actually 7.50%. 7.50% is our final answer. It is a positive number, which means that in this experiment, Kayla came over the accepted value. The accepted value is 1.00. She came higher at 1.075. Therefore, the answer is a positive percentage. Practice problem number 3 states, an object has a mass of 35.0 grams. On Anthony's balance, it weighs 34.85 grams. What is the percent error of his balance? First step, write the formula. Percent E equals M minus A over A times 100. Then we have to find the measured and accepted values. The object has a mass of 35.0 grams. That's the accepted. However, on Anthony's balance, Anthony's doing the measuring, and he finds it to be 34.85 grams. That is the measured. Next step, we plug it in. So we have percent E equals measured 34.85 G's minus accepted 35.0 G's over the accepted value 35.0 G's times 100. Once again, take it one step at a time. So you have 34.85 minus 35. I would do that first. 34.85 minus 35, which is going to give you a negative 0.15 grams, divided by 35.0 times 100. So you take your negative 0.15 divided by 35.0. The grams and grams cancel out. So I'm left with a very long number, negative 0.004285714 times 100. Before we go any further, I would do significant figures now to make life a little bit easier. So I have 35.0 has 3 significant figures. 34.85 has 4, so the least number is 3. Go to the first significant figure, 1, 2, 3. 5. 5 and above, we round up. So we're left with negative 0.00429 times 10 times 100 times 10 to the second. And if we were to finish this problem, 0.00429 times 100, we would decimal place over 2 times, so we get negative 0.429%. It's a negative percentage because Anthony's balance came in under the accepted value. The accepted value was 35. The scale read it out as 34.85, which is, of course, below the accepted. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned about percent error. We learned that the percent error formula is percent error equals measured minus accepted over accepted times 100. And we learned how to use that formula to calculate the amount that the measured value is off from the accepted value. Remember, If the measured value is lower than the accepted value, your percent error is going to be negative. However, if your measured value is higher than the accepted value, then your percent error is going to be positive. Thank you again for joining us. I hope you learned something today. Please join us again soon.